Stanford University.
All right, well, welcome to Lecture 4 then of CS193P for fall of 2013/14, academic year 2013-14. Today I'm going to do pretty much all slides. I do have one brief time when we'll stop and do a little demo. And then at the beginning of next lecture, I'll be doing a demo that pretty much demonstrates the vast majority of what I talk about in the slides today. And remember, that's kind of how it's always going to go. I'll show it to you in slides, we'll talk about it, then I'll demo it to you, because when you see a demo, it all makes a lot more sense than if someone's just talking in the abstract conceptually about an API. And then your homework is usually going to ask you to do this, so it's, you get a lot out of paying attention in the lectures, because I'm pretty much going to give you hints and basically tell you a lot of how to do the homework, at least from the iOS side of it. I'm still going to ask you to do the thinking side of it, the designing side of it. So today we're going to start off by talking about a little bit more miscellaneous Objective-C, and then I'm going to go into talking about Foundation, which is this framework that has arrays and dictionaries and all that in it. And we'll start to transition out of Foundation at the end of that and start talking about things like fonts and colors, which are obviously not in Foundation, because Foundation is really not a UI-based thing. It's for building both your model and your controller and your view, but it's a layer below the user interface layer. So let's dive right in. Let's talk about creating objects. A few of these things are pretty obvious, I hope, but I just want to put them on slides so that you have them in writing here. You know that most of the time when we create objects in the heap, we do it with this alloc init business, right? So sometimes the init is just init, like NS mutable array alloc init, and sometimes it's more complicated init, like we had with our card matching game, init with card count using dec, so that you're used to that. And you've also seen us create objects in the heap using class methods, like string with format. Remember, we did NSString, string with format, and that's a class method, right? Because it's open square bracket, name of a class, and then class method. So that's kind of two different ways you've seen already to create objects. Sometimes for some methods, there's both an init and a class method. So string with format is an example of that. There's alloc init with format, and there's NSString, string with format. They do exactly the same thing. Both of them are there for kind of historical reasons. Back before we had this automatic reference counting, the strong and weak thing, you had to be much more explicit about things when you were going to reference them and when they got dereferenced and when you cleared them out of the heap and all that stuff. And one of the ways that was done was using these class methods to create the string in a way that it would get released in a certain way. So all that doesn't matter anymore. So now we're kind of stuck with having both of these things. It seems to me that iOS, the designers at Apple, I don't work at Apple, by the way. Some people have asked, you work at Apple? I don't work at Apple, so I'm just seeing iOS from the outside just like you are. It looks to me like iOS people are moving towards alloc init, okay, and kind of away from the class methods, although I still see the class methods coming up in certain circumstances too, and there's probably some reasoning behind it. I haven't seen it put in writing by Apple as to when they choose which, but you're certainly safe in this class until they start marking some of these things as deprecated, like don't use them anymore, to use either form, okay? I tend to try to go for the alloc inits most of the time, unless there isn't an alloc init that does what I want. Then I'll use a class method. But there's other ways to create objects, okay? You can create objects by asking another object to create an object for you. So that's like string by appending string. That's not a class method in string. That's an instance method. You send it to another string. You give it a second string, and it will create a new string for you. Since strings are immutable, NSString is immutable, it creates a new string that is the string you sent it to with the one you passed as an argument added on, right? So there it's creating a new object for you, okay? And a very interesting method, instance method that you can ask an object to do for you is mutable copy. Okay, and so mutable copy makes a copy of an object, but it's mutable. So if you have an NS string and you send it mutable copy, you'll get back an NS mutable string. Or if you have an NS array and you send it mutable copy, you'll get an NS mutable array. So that's another way that happens, that you're creating objects. Of course, not all methods that return an object are creating an object, like we saw in NSArray, last object and first object, and object at index. Those aren't creating new objects. They're just giving you pointers to the objects that are in those array. Okay, that should be completely obvious to you, but just want to make it clear, these are pointers to objects, and you're allowed to have multiple pointers, and this is normal pointers here being passed around. Okay? So basically, unless a method has the word copy in it, then if it's returning to you an object that exists somewhere else, it's going to be returning a pointer to that object. Okay? Unless it has the word copy in it, like mutable copy or copy. And if the object that you're getting back doesn't exist somewhere, then it's going to make a new one for you. All right, that's it on creating objects. Pretty straightforward there. Okay, nil, I already talked about this, that we can send messages through a pointer that is nil, i.e. that pointer does not point to anything, and no code gets executed. So if I do this int I equals obj method which returns an int, no code gets executed to execute method which returns an int. However, that message sending square bracket thing will return 0. Okay? So that's important to know. And 0 is also what nil is. So if you had a method that returned an object and you sent that message to nil, then you'd get back nil. Okay? And we can use that actually to our advantage. For example, in our thing we did on Monday, we did draw a random card, right? Self.deck, draw a random card. And that returned nil if the deck was out of cards. Okay? If the deck itself had been nil, that also would return nil. So we can write one if that deals with the fact that we can't get another card, whether it's because the deck is empty or because there is no deck because the deck is nil. Either way, the code's going to look exactly the same. Okay? So you'll get used to that. It's definitely different from other languages where you're protecting against sending messages to nil, but you'll get used to it. You do have to be careful if the return type of message send is a struct, because you don't get back a struct with all its members set to 0. You get back an undefined struct. Okay, what's in there is undefined. Okay, the struct is being returned to you on the stack. You might get stack garbage. You might get zeroed out struct. You just don't know. So you can't rely on it. So here, you should never rely on that in your code. Okay, if you call a method that returns a struct, you've got to check to make sure you're not sending it to nil. Okay? All right, dynamic binding. So ObjectiveC handles the dispatching and calling of methods differently than languages that most of you are used to. It does what's called dynamic binding. Okay? And you'll see what dynamic binding is as we go through this slide. But the important thing to understand about dynamic binding and about ObjectiveC is that there's a really, really important type in ObjectiveC called ID. Okay? We call it ID. We don't call it id, by the way. ID, we call it. So here, that line of code, I would say that's ID, my object. Okay? So I'm declaring a pointer, my object, which is a type ID. So ID means pointer. ID is a pointer. So we don't use ID star. ID is a pointer. It means a pointer to an object where I don't know its class, okay, of unknown type or unspecified type. Okay, so it's just a pointer to an object. I do not know anything about that object. Really, all pointers in Objective-C are IDs, in that the decision about what code to execute when you send a message to an object is not determined until runtime when you send that message. Okay? When you send a message, it's essentially calling a function that's looking up the right code to execute for that particular class that you're pointing to at the time you send the message. Okay? That's called dynamic or late binding. Okay? And all message sends, all of them in Objective-C, are done this way. Okay? Now, what does this mean? All right? It means that, well, is this safe, right? Because you're worried, I'm sure, what if I send a message to an object and it doesn't understand it? Okay? Well, nothing stops you from doing that. And not only that, if you do that, your program will crash. Okay? It'll raise an exception. Unless you catch the exception, it will crash. And so you're probably feeling like, wow, these Objective-C programs must be crashing all the time because you accidentally send a message to an object. It doesn't understand that message. But actually, it doesn't happen. Okay? Why doesn't that happen? And there's really two reasons. One is we use static typing a lot. We don't use ID that much. We use like ns-string star. Now, ns-string star is exactly the same as using ID, except that the compiler, while it's compiling your code, knows that you at least intend that that pointer points to a string. So if you try to send a non-string message to that pointer, it's going to complain. It's going to, give you warnings. And so when you compile your Objective-C programs, they should always have no warnings. And then you can be pretty sure that you're not going to have this problem where you send a message to an object at runtime and it doesn't understand it and it crashes. Okay? So that's the number one way. And And the second way I'm going to talk about is that a lot of times we will check at runtime. We'll look at that ID pointer, okay, and we will check and see if it responds to something before we send it, okay? So you know about static typing. That's the ns string star s equals @x. This is really safe, really good. Nothing bad's going to happen here because the compiler at compile time has a pretty good idea of what you intend, and it will warn you if not. However, it's still not, the compiler is not doing the binding between what code executes at this time. It's just warning you. It's syntactic sugar. Okay, it's syntax that it can look at to warn you, but it's not actually enforcing anything here. It's perfectly legal to say id obj equals s, where s is the line before. Okay, and that will not even generate a warning. Because id obj is a pointer to any kind of object, s is a pointer to any kind of object. It's a pointer to a string, according to the previous line, but since those are both pointers to objects, that's perfectly legal. Compiler will not warn you. This is a little bit of a dangerous line of code, right? Because you just went from having s, this nice variable that's typed and the compiler can warn you if you do the wrong thing, to having obj, which is this untyped pointer where you can send any message you want and the compiler's not going to warn you. Okay? You can also do this. NSArray star a equals obj. Okay, now you have an NSArray variable that points to a string. Well, that's extremely likely to cause a problem. Okay? This is also legal because NSArray star a is a pointer to an object. Obj is a pointer to an object, so it allows this assignment. Very dangerous, obviously wrong. If these three lines of code are there, that's clearly wrong. You would not want to have an NSArray pointing to an NS string. Okay? But so ID can be dangerous in this way. And in fact, in the code that we've written, we already did this, kind of silently. Remember that in match, playing cards match, we put a line in there that said playing card star other card equals other card's first object. Remember that? Well, the method first object in NSArray returns an ID. If you go look it up in the documentation, look at its return type, parentheses ID. Okay, so we just assigned a playing card to an ID. So that object that came out of that array better be a playing card or we're going to crash at runtime. And a little later in this lecture, I'm going to show you how we can protect our code to make sure that we don't crash in this case. Okay? But does everyone see why this is a little dangerous? Right? Questions about that? Okay, and a reminder, never use ID star. ID star makes no sense because ID is a pointer. So ID star would be a pointer to a pointer. And we don't do that in ObjectiveC, okay? Especially a pointer to an ID, we would never do. All right, so to summarize all this, I'm going to show you this example. I've got two classes. I got a vehicle class, which has a method move. You can move the vehicle around. And I got a ship, which is a vehicle, inherits from vehicle, and it's only got one method, shoot. So this ships can shoot other ships, and they can also move because they're vehicles. Okay? So if I declare a local variable, ship s, which is a ship star, and I allocate an init a ship, I can say s shoot or s move, works fine, right? Because ships implement shoot and they inherit move, so everybody's totally happy here. I can also do vehicle star v equals s. That's perfectly legal because v is a vehicle and s is a vehicle because it inherits its vehicleness from ship. Okay, this is like deck equals playing card deck alloc init. Perfectly legal object-oriented programming, right? Okay, but now let's try to say v shoot. Okay, now what's going to happen here? All right, at compile time, you're going to get a warning because vehicles do not implement shoot. Ships do, but not vehicles. So do you see why this is going to give you a warning? Okay, what about at runtime? This code will not crash because we know that v actually is a ship. So this will work fine at runtime. Okay? See that? So that's where you get, this is the example where you get a warning at compile time, runs fine at runtime. Okay? Now, what about this case where I declare an obj, okay, and it can be anything we want, okay, you alloc init it somehow, and you say obj shoot, okay? No matter what obj is,